All right, hi guys. Hello. Hope you guys are doing great. So today I'll be attempting this Leetcode Biweekly contest 98. So I'm just reviving from an extremely horrible performance in the AdCoder regular contest, which was conducted earlier in this evening. So I'm kind of hoping to mask all that sadness with a comparatively good performance here, right? So yeah, let's see how this goes. All right, let's load all the problems. All right, problem A. So you are given an integer and you know that someone will sneakily remap one of the 10 possible digits to another digit. Return the difference between the maximum and the minimum values that he can make by remapping exactly one digit. Yeah, okay, this makes sense. Yeah, this perfectly makes sense. So one thing that we can do is we can just apply brute force. So we can map every digit to every other digit and just check their difference. Okay, that's one thing that we can do. Hmm. Or what's the other thing? We need the maximum possible difference by remapping a digit. So basically, what's the minimum possible number that we can get here? Let's think about that. So the minimum possible number is obviously going to be uh, the one in which we set the MSB to 0. And the maximum possible number is one in which we set the MSB to 9. Okay, so I think that's it. That's pretty much it, I guess. Hmm. Yeah. So let's do something like this. Let's create two strings, okay? So initially S1 and S2 both are equal to num. And then what I'll do is I'll say S1 is, or maybe let's say that both of them are equal to the to num, but not their not the MSB of num, right? And excluding the MSB of num. And then what we can do here is, so we can first of all reverse it, or maybe we don't even need to reverse it. So we can say S1 is equal to 9 plus S1 and S2 is equals to 0 plus S2. Okay. Instead, we can just skip this step and we can just return a string to integer of S1 minus string to integer of S2. Right. So we'll just add 9 to it. So yeah, this makes sense to me. Let's run and check. So we are getting 9,000, which is wrong. Now, why is that? Oh, okay, yeah. So we can't do that. We can't do things like that. So we'll just have to construct both the numbers. So that's not a problem. So let's just say S1 is equal to S2 is equal to string of num. Okay. So in S1, essentially what we need to do is wherever we find the MSB, we are going to change it to 0. Okay. So, so if X, yeah. So we'll check if X is equal to the first character, which is nothing but S1 of 0, or maybe let's create another string S, which is equal to string of num. And let's say that both S1 and S2 are equal to S. And then we can say if X is equal to S of 0, then we'll just change X to 9. And we'll do the same thing for S2, but this time we'll change it to 0. Okay. And we're going to change it to 0. And now we are going to return string to LL of S1 minus string to LL of S2. 99009 and 90. Okay, so again we're getting something wrong. The maximum value can be returned by the function is 99 and the minimum value function is 0. Yeah. Hmm. So what's S1 and S2 here? So in 90, essentially, we need to map, for S2, we'll map all the nines to zeros. So it should be 0, right? Ah, I see now. So if the first character is already 9, then we are just mapping a 9 with a 9, which is not beneficial. Okay, that makes sense. So then what should we do? Hmm? All right, so let's just apply some kind of brute force here because I think that's what they want us to do. Hmm. Okay, so another way to do this is to just find the first character which is not equal to 9 and then change it to 9. Okay, so let's have two characters, ch1 and ch2. Okay, ch1, let's say that it is 9, then we'll iterate on the string s. Okay, and we'll say if x is not equal to 9, then we'll just assign ch1 to be equal to x and then we'll break. Yeah. Hmm. And here, instead of checking it to be s of 0, we'll check it to be ch1. Now we'll do the exact same thing, but here we'll say that ch2 is equal to 0. We'll iterate on s, we'll check if it is not equal to 0. Then we'll assign ch2 is equal to x. And now we'll check if x is equal to ch2. And then we'll assign it to be 0. Okay. Yeah, so hopefully this should work now. 1, 1, 0, 0, 1, and 99. This is wrong again, I guess. Now why is that? So can we not see our custom output here? Oh, oops, it's my bad. 0 and 1, 0 and 9. Why is ch1 equal to 0? Uh, we should initialize ch2 by a 0 here. Yeah, 99009 and 99. Now it looks correct. So let's submit this. Cool. Let's move on to problem B. Problem A took a lot of time, much more than what I expected. So you are given a zero indexed array nums. The low score of nums is the minimum value of this over all ij, all right? And the high score of nums is the maximum value of this over all ij. Cool, cool, cool. So the score of nums is the sum of the high and the low score of nums. Okay, to minimize the score of nums, we can change the value of at most two elements of nums. So return the minimum possible score after changing the value of at most two element of nums. All right, so I see what we're doing here. So it makes sense to sort the array first. So the low score is going to be the minimum difference between any two elements. Okay, and the high score is going to be the sum of the last element and the first element. Okay. Hmm. So what can be done here? I think what we can do is we can make the first element equal to the second element and the last element equal to the second last element. In this way, we are minimizing both the uh, low value and the high value and hence their sums, right? So what can we do here? We can say that sort nums dot begin, nums dot end, and then we can just return essentially nums of, so let's say int n is equal to nums dot size. So we'll just return the difference of the second last element and the second element, which is nums of n minus 2 minus nums of 1. Okay. Okay, yeah. So yeah, this should be the answer. For 1, 4, 3, we are getting 0. That is correct. So 0 and 3 make sense. Let's submit. Oh, oops. So we are getting a wrong answer here. So the expected output is 14. Okay, what did I miss here? Hmm. Okay, so we are given a zero indexed array nums. We say that an integer x is expressible from nums if there exists some integers for which the bitwise, so basically there exists a subsequence whose bitwise OR is equal to x. Okay, an integer is expressible if it can be written. Okay, so we need to return the minimum positive non-integer, non-zero integer that is not expressible from nums. Okay, makes sense. Ah, okay, so another thing that we can do here is, so we can like change the second element and make it equal to the third element. So all the first three elements are the same now. Yeah, that makes sense. So answer is going to be the minimum of three values essentially. Right, so the first value is this, no problems there. So the second value is essentially going to be nums of n minus 1 minus nums of 2. And the third value is going to be nums of n minus 3 minus nums of 0. So let's add this to the test cases and try to run. Okay, let's submit this now, should work. All right, so now when is a number expressible? Let's think about this. Hmm. bitwise or of some subsequence of numbers. One observation here is that if we look at the minimum element of the array, the bitwise OR is always going to be more than that minimum element. Okay. So if 0 is not present in the array, sorry, if 1 is not present in the array, then the answer is always going to be 1, right? Cool. Now we know that 1 is present in the array. So let's think about 2. Hmm. So if 2 is not present in the array, then what happens? So yeah, if 2 is not present in the array, then again we can never form 2. Yeah, that makes sense. So let's now talk about 3. What happens with 3? So if 1 and 2 are present, then we can obviously form a 3, right? Yeah. So let's focus only on powers of 2 and think about which powers of 2 are present in the array. Okay. So now let's talk about 4. So if 4 is not present in the array, then is there any way we can get a bitwise OR of 4? It's not possible, obviously, for obvious reasons. So if 4 is not present in the array, then the answer is always equal to 4. And the answer obviously is greater than 3. Then the answer is 4. But now let's see what happens when 4 is indeed present. So now we know that 4, 2, and 1 all are present in the array. So we can use these numbers and we can have any number which contains these three bits. So I claim that the answer is always going to be some power, always going to be the first power of 2 which is not present in the array. And the proof again is pretty obvious here. Cool, makes sense. So let's just keep a map. So map from, let's use long longs. So map from long long to long long count. We'll just iterate on our array and we'll say count of x plus plus. So now currently we first look at 1. Okay. So while 1, let's have a while loop. So if count of cur is equal to 0, you can simply return cur, else you can say cur into equals to 2. I think this is enough. Yeah, should be good. All right, let's move on to the last problem. So you are given two zero-indexed arrays, nums1 and nums2, and a 2D array queries. So there are three types of queries that we need to handle. For the queries of type 1, uh, 1 LR. So basically we need to flip the values from 0 to 1 and 1 to 0 in nums1 from L to R. Makes sense? All right, so for queries of type 2, we basically are given an integer p. Right. Okay, so for every index I in 0 to n, set nums2 of I is equal to nums2 of I plus nums1 of I into p. Yeah, makes sense. So only three people have solved it till now, which seems kind of fishy. So return an array containing the answers to all the queries. So if you need to find the sum of all the elements in nums2. Hmm. All right, so let's see how we can solve this. The constraints obviously are quite large. Queries of type 1 can still be handled pretty easily. Hmm. So this array nums2 is essentially kind of useless to me, right? Yeah. All we care about are the number of ones which are present in the array nums1, and all I care about is the sum of all the elements in nums2. Okay. Yeah, that makes sense. Yeah, we only need to care about the sum of elements in nums2, so that's okay. So the sum will only increase by p times the number of ones in our array. Cool, that makes sense. So all we need to do is to somehow keep track of the number of ones present in this array. Okay. Yeah, makes sense. Now I know how to solve this using a segment tree, but I don't really want to use one. There almost always exists an easier solution to such problems, and I mean, I want to try my best to find that out. But yeah, okay, let's see. Or maybe we can just use a segment tree and get it over with. There is no harm in that as well. So yeah, let's do that. When will this awesome template help me, right? Right, let's use a segment tree. The thing to note here is that what we need to do is we just need a lazy segment tree which handles all these updates. And then all we need to care about is the sum of all the elements in the segment tree, which can be found out using a query. And then pretty easily we can just find out the sum of all the elements in nums2. We can essentially just maintain it, right? Yeah. Okay, cool. Let's do this. So let's just edit everything that we want to edit. So this is good because we just want the sum. Now let's change these two functions. So again, since we are interested in finding out the sum, yeah, now the update means that we are changing the ones to zeros. So that part might be a bit tricky. So let's see how we can update. So essentially what we have here is that we have a current node which has some value stored, and we have an update. Okay. So what will an update look like? So an update basically means the number of times we are we are flipping the range L to R. Okay. So if we are trying to apply the update, then essentially all we need to do is to check the parity of the update. So if the number of times we apply this update is even, then we don't really need to do anything. So we can just say the answer is equal to cur. Else, what we need to do is we just need to say all the ones are zeros and all the zeros are ones. So the answer is equal to tr minus tl plus 1 minus cur. Okay, then we can return the answer. And now how do we combine these two updates? Yeah, so this is the old update and this is the new update, and my answer will be old update plus new update, right? So answer plus equal to new update. So this update just means how many times am I actually flipping this range. So I can just combine these updates by summing them up, and I can just apply the update by checking if the number of times I'm flipping is even or odd. Okay, hopefully that makes sense. So this is what the segment tree means. Right. Now, what do we need here? So we need to maintain some variables. So let's say answer, which is initially equal to the sum of all the elements in nums2. So nums2 dot begin, nums2 dot end, and 0, right? Yeah, let's just have a look at the constraints. Yeah, so nums2, the elements can be large. Is there any modulo somewhere? Nope. Cool. Or maybe this might just generate an error. So let's initialize it by 0. Cool. So now we know our initial answer, which is the sum of all the elements in nums2. And now let's go to the queries. Obviously, we need a segment tree. So let's say, so nums1 copy. Okay. And also a variable n. N is equal to nums1 dot size. So the size of this copy is going to be n. So we'll say nums1 copy of I is equal to nums of I. Cool, 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 cool. So now we can build this segment tree. So let's have a segment tree. So the queries are going to be long, long, and the updates are again going to be long, long. So let's name it ST. Size is going to be n. And the identity element here is going to be 0 because we're talking about sums. And the identity update is also going to be 0. Okay. So then we'll say that st.build, and we'll pass the nums1 copy array. Cool. So now we have our segment tree. So all we need to do is iterate on the queries. So let's do that. Okay. So the type is going to be q of 0. So let's see what happens if the type of the query is equal to 1. So now if the type of the query is equal to 1, all we need to do is we need to flip the values between this range and this range. Okay. So that's easy. So we'll just update our segment tree, and we'll say st.update q1, q2, and we are flipping it once, so we'll pass it 1. Else if type is equal to 2, now what we need to do? So we need to increase the answer, right? Yeah. So the number of ones, so the number of ones is going to be st.query from 0 to n minus 1. Okay, and we'll say answer plus equal to p into the number of ones, where p is what? P is q of 1. So answer plus equal to q of 1 into ones, right? Else we just need to output the answer. So we will push the answer in a vector. So let's say ansvec dot push back answer, right? Hopefully this makes sense. So now we'll just return ansvec. Line 48. Yeah, yeah. So this should be nums1. Ah, so let's replace this sz by a dot size. So we're getting a 3, which seems correct here. Let's use all the test cases and just try to run it once. So we're getting a 3 and 5, which is again correct. Are these test cases even a little bit exhaustive? All right, let's just submit and check if this works, because I don't think the samples are helpful at all. Okay, what's happened here? So what's wrong here? How can we even get a runtime error? Heap buffer overflow. What's that? Hmm. Maybe we are reinitializing all the memory here. Maybe that's the problem. So let's just say that we have our segment tree as a global member. So lsec tree ll comma llst. So what's the maximum possible size? It's 10 raised to the power 5, hopefully. Yeah. So let's say lln is equals to 10 raised to the power 5. So the size is going to be n and 0 and 0. And instead of building, what we can do is we can iterate over all the i's and say that sectree.update. So we'll just check whatever is present here. So ll here is equal to st.query I comma I. So if here is not equal to nums1 of I, we'll say that st.update I comma I and 1. Yeah. Now let's see what happens. We're getting a 3 and a 5. That's okay. But now let's see why on earth were we even getting a runtime error. Types are 1, 2, and 3. LR are 0 indexed. That's not a problem. Nums1 of I into P. So answer will increase by P into the number of ones. Find the sum of elements in nums2. Hmm. Ones is st.query 0 to n minus 1. That's okay. Okay, let's see what they've got here. So it's accepted. So one thing that I'm not really sure is that how they run the test cases, because just making the segment tree as a global element passes the test cases. So that's kind of weird, but I think that's all right, because I have some experience with solving such problems on HackerRank and HackerEarth, where if you magically, just put some elements from your code to the global heap memory, then it just kind of magically works. So maybe it's that all the memory that you use inside of your code is added up on all the test cases that they run. So maybe that might be the reason. But anyways, a general advice is if you're getting a runtime error, then it's like kind of probable that that might be the reason. Okay. So how are we doing? Not so good apparently. Yeah, so this shows that only 190 people, only 200 people have solved it, but still my rank doesn't reflect it. Also, it's pretty awesome that Range Raghav has got rank 1. So yeah, congrats on that. Yeah, all over, I would say pretty good round. Yeah, that's it. So I'll just stop recording now.